project. We clarified the project, also clarified the issue of that last test. Remember also that you have another test, another homework to submit on Thursday, and another test on Sunday.
Yes, sir.
Now, I think that's the homework submission on Sunday. Let me just double check.
Sunday and Tuesday.
Ah, okay. So next Sunday the submission and the test is on Tuesday. Yes.
دكتور بالسيلابوس اختبار الرابع والفاينل بنفس اليوم
أي final.
ولا
لا لا لا.
مو بنفس اليوم يعني؟
الاختبار الرابع الأسبوع الجاي الثلاثاء.
الثلاثاء
إيه ما في فاينل لسه.
ما في اختبار
ما قال في فاينل دكتور من اول.
أعلنوا الفاينلز لكم في الويب سايت.
مكتوب في موقع الريجسترار يا دكتور تاريخ 20 جولاي في فاينل للمادة بس ما ادري الصراحة.
طيب اوكي خلاص جولاي 20 في فاينل. ما له علاقة هذا احنا في الاسسمنت. قصدك انت الاسبوع الجاي الثلاثاء
دكتور انت قلت في فاينل في المادة.
ايوه في فاينل 20 جولاي. الفاينلز في الجامعة كلها تتبع الاناونسمنتس اللي تعلنها الجامعة. في بداية السمستر ما اعلنوا لان لسه قاعدين يفكرون في الموضوع الى الان. بس خلاص بما انه اعلن في موقع الريجستر عن 20 جولاي فمعناه الموعد 20 جولاي يعني احنا ما نغيره اصلا.
دكتور راح يكون comprehensive الفاينل.
الاسبوع الجاي نتكلم عنه بس غالبا ايوه. لان احنا ما نقدر نفصل 3 فيس عن الماشينز مثل ما انتم شايفين. الماجنتيك كور عن الماشينز يعني الماتيريال كله مرتبط تقريبا ببعضه. بس الاسبوع الجاي احنا نتكلم عن الموضوع ان شاء الله. اوكي طيب اوكي so let's continue with the material, and today we're going to discuss basically how, which is, we discussed this also with the transformer if you remember, which is how we can find parameters using what we call open circuit test and short circuit test. So the main objective of this practice is to find the machine parameters. And remember, for synchronous machines, we have two parameters. We have mainly RA and reactance, synchronous reactance. So yes, the objective actually is to apply these two tests to find mainly XS. So we apply open circuit test and short circuit test to find XS. What about RA? RA, we will apply what we call DC voltage test to find this RA. So the open circuit and the short circuit will be both of them for XS, and the DC voltage test will be for RA. So we're gonna go through them one by one. But when we say open circuit test, it means that we don't have load. The load is disconnected, and we just apply the rated speed, and we measure the voltage at the output. So this is the idea here, and I'm gonna explain also what we're gonna get for this. So we leave this open circuit, we fix the speed, and we measure the voltage, which is gonna be the same as EA. Do you agree? Same thing. There's no current. And we measure the voltage when we're changing basically the field current. So we change this. And you're gonna do this in the lab tomorrow and after tomorrow.
Today and tomorrow.
Yeah, today and tomorrow, sorry. So IF, you will change IF, and each time you measure or record what's the value of terminal voltage. This is for the open circuit test. For the short circuit test, Well, you make this short circuit. Again, you apply or drive the machine for rated speed. And now you measure the armature current. Each time when you are changing also the field current. So you change this and you measure the field current. So for the open circuit test, you measure what's the voltage. For the short circuit test, you measure what is the armature current. And from the armature voltage and the armature current, you find what's the value of XS. Okay? So let's go through them one by one. First, the resistance test or the DC test. Well, the idea is simple here. We know that we have both RA and XS inside the machine. What will happen if we apply DC here? Well, so we in the lab, what will happen if we basically just connect a DC source between this point and this point? Well, current will flow here. Do you agree? And the current will be DC current.
Yes.
Yes.
Why? Because we have a resistance. So if we can measure the voltage here and we can measure the current here, what will happen? RA, which is Ohm's law, will be voltage DC divided by current DC. That's it. Someone might ask, what about XS? What do you think, guys? What about XS?
ما منها فايدة شورت سيركت تصير.
زيرو.
Yes, this will not have any effect because this is DC. Now we are applying DC. So in DC, the inductor will be like a short circuit. So that's it. It is the only parameter that we are going to have in the circuit will be RA. And this is why it's called DC test or resistance test, because here the only factor that will affect the voltage and current will be RA. Okay? Now, this value, it's not completely RA. We're going to call it RL. Why? Because remember that we have different connections for the three-phase side. We have either Y connection or delta connection for the machine. So if you apply the test on Y connection, you are going to have two terminals like this, and you apply voltage DC. Okay? What will happen now if you apply the test like this? Between the terminals or the line terminals of the Y connection. What will happen is that the current will flow. And you will basically, if you divide the voltage that you are applying to the current you are getting, you will get RL. What is going to be RL here in this case if we have Y connection? So this is open circuit. It's not used. This is not connected. So the current will go through here, and after that will go through here. So whatever resistance we are calculating here, it's going to be
VDC over 2R.
Yeah, exactly. It's going to be like two resistors in series. So RL will be two RAs, not only one. Okay? Which is RA plus RA. So to find the value of RA, we divide whatever we got from the test by 2. Why? Because whatever we got from the test, if it is Y connection, it's going to be 2 RAs. If we apply the test between the line to line. Is it clear?
Yes.
What if we do it line to line and the connection is delta? Well, first of all, this is voltage DC, this is current DC. So if we divide same thing, we will get resistance value. But what is this resistance value? First of all, the current will flow in both, right? And all the resistors we have in this connection. But again, what is the value of RL? Well, RL will be the equivalent. And what will be the equivalent in this case?
Two of them are series.
over three.
and one in
Yes,
parallel.
these two in series and one in parallel. So 2RA multiply RA divided by, do you agree?
Yes.
So this will be cancelled with this. So RA will be 1.5 RL. So whatever we got the resistance out of this test, it's actually 1.5 RL. Sorry, RA, yeah, RA will be 1.5 multiplied by the resistance out of this test. Is it clear? Any question here? So it depends on the connection. If it is Y connection, you apply the test, you find the value of the resistance between the terminals, and RA will be 0.5 of that resistance. If it is delta, you apply the test, you find the resistance between the two terminals, RA will be 1.5, whatever we find on that test.
Doctor,
Mm-hmm.
I guess this is the generator side. If it's true, why are you putting the resistance is not the voltages, not the load side?
معلش again, I didn't get the question.
I mean, this is the generator, and it's in the voltage side, in the Y connection,
Okay.
right?
Yes.
So you are putting resistances as it is if it was in the load side, not the generation side.
Yeah, but remember that RA, first of all, the complete circuit will be like this, without XS, because this is DC, right? So, yes, if the load is connected delta or Y, it's like basically we are connecting these two terminals to either delta or Y.
Mhm.
So, the connection will be actually like this. One armature circuit like this, another armature circuit like this, the third armature circuit like this. Get my point?
Yes.
So this is Y connection. This is how we connect the three armature circuits in Y. Doesn't
So
mean that the load is connected. It's basically the whole machine is connected in either Y or delta.
So basically, what you're saying, there are no voltage induced in the synchronous machine.
Yeah, there is no voltage induced because we are not running the machine. Okay, we are not running the machine basically here, so we don't provide here any speed.
Okay.
Zero. Because if we provide speed and field current, this is AC circuit. We don't want this to be AC circuit. We want it to be DC. So nothing here as an input for the machine. The machine is off. You just apply, as I mentioned, DC voltage.
Okay. Thank you.
Any other questions? So we will go to the open circuit test, and the objective here for the open circuit test is to measure the value of XS. So we know how to find RA. Now we want to find the XS. And now we are going to assume that RA is neglected because XS will dominate RA. So we'll leave all the terminals here open circuit. So we don't connect, and this is Y connection. We leave this open circuit and this between this and this open circuit. So this is A, B, and C open circuit, all of them. We don't connect any load. We just connect voltmeter here between A and B and a meter in the field side. So what we're gonna do, we will start to change the voltage source here for the field. And of course, this will change the current that we inject to the field. And what will happen if we start increasing the field current? The voltage here will start to increase, right? So each time we are changing the current, we record what will be the voltage between the two terminals of the machine. That's it. So at the end, we are going to have a curve. You remember what was the name of this curve? It is the magnetization curve, or BH curve, right? Similar thing, but it's between voltage and field current. Same behavior. So this is the open circuit test. It's easy. We leave all the terminals open circuit. We connect voltmeter. We change the current. We connect a meter to the field circuit. And we keep increasing the field current till we reach the rated value. And each time a step, or each step of the field current, we record what's the voltage. What about the short circuit test? Well, short circuit, we make all the terminals here short circuits, and we connect an ammeter to between A and B. Of course, the ammeter works as a short circuit, so it's still short circuit, but we measure also the current. We connect also the same ammeter that we had before in the open circuit test. We change the field current. We record each time what will be IA. And that's it. This is called the short circuit characteristic curve. And we draw also the relation between them. So what? I mean, we got now the curve from the short circuit test. We got the curve from the open circuit test. How we can find XS? Well, this is the open circuit test. And as I mentioned, it's like the magnetization curve. This is the short circuit test. And our objective is to find what's the value of XS. So the value of XS will be the voltage from the open circuit test divided by the current from the short circuit test. But which voltage, which current? This is the question here. Well, this is very important question. Because you remember that for the voltages, we have many voltages here. For the currents also, we have many currents because we kept changing IF. Well, we need to fix the value of IF. So the voltage here will be for the rated voltage. Okay, so that's why we're changing the field current till we get the rated voltage. The current here will be for the same field current that we used in the rated voltage. So if we know exactly what's the value of the field current that will give us the rated voltage, we use also the same value of the field current in the short circuit test to find what is the short circuit current. So it goes like this. We have two curves. We draw all of them or both of them in the same circuit. And the rated voltage current, face rated voltage current, that we find the corresponding field current from the open circuit test. So you go to the open circuit characteristic curve and find what was the field current that will give us the rated voltage in the machine. Once we know what is the field current, we go to the short circuit test and we know from the other curve what's the corresponding value of the short circuit current. Then what? XS now will be this value divided by this value. And that's it. Any question regarding this? So it's a very simple, basically, procedure, but we need to draw both curves till we reach this point because this is more of intersection between the two curves. And of course, you need to record all the values in a table, or after that find what's the common IF between the two tests. If we draw the OCC, the open circuit characteristic curve, as is from the test, we'll have nonlinear curve. If we draw the theoretical one, which is basically what's called the slope for this one, it's called the air gap line. So air gap line, it's like the theoretical version of this open circuit characteristic curve. So either we use this or we use this. Based on what? Well, this is very important also. If we... I didn't mention one thing. Yeah, this is not XS. This will be the impedance, yeah. This is the whole impedance if we divide the voltage by the current, yes. Because remember, we have also RA. So XS and RA. So if we divide the voltage by the current, we're going to get the whole value here, or the magnitude of the whole value here. So we will get the magnitude of the impedance, which is enough. Why? Because after that, we know what is RA. We know that the value of the impedance, Z is equal RA plus JXS, and the magnitude will be equal square root of RA square plus XS square. So if we know this from the open circuit and short circuit test, and we know this from the DC test, we can know the value of XS. Okay? Just to explain also the value that we get from the OCC, or the value that we get from the what we call the air gap line. The value that we get, or the recorded value of the reactance that we get from the OCC, it's called the saturated reactance. The value that we get from the air gap line is called the unsaturated reactance. So the reactance will be different if we assume that the curve is theoretical or air gap, what's called air gap line, or it's if we assume the more practical curve, which is the magnetization curve, or the OCC. And of course, you know the meaning of saturated. Saturated means that we include the saturation into the calculation, which is more practical. Unsaturated, it means that we are not including this in our calculation. Yes, any question?
هذا دكتور unsaturated بيكون في الثيوريتيكال.
Yes, using the air gap line. So if I ask you find the unsaturated reactance, you use the air gap line, which is the same procedure that I explained before. If I ask you to find the saturated reactance, you use the OCC.
استخدم الأوس. Yes.
Yeah. So for example, if I ask you find the unsaturated reactance,
مع البلو line.
the blue one, yes. The rated voltage is here. You go to this curve or line, find the corresponding IF, and after that you go back to this curve to find IA, I short circuit. So the Z unsaturated now will be this voltage divided by this voltage.
By this one.
Okay?
Yes.
دكتور
Yes.
بالنسبة اللي هو الكيرف حق الكرنت ليش لينير بينما حق الأوبن سيركت ما هو لينير يعني؟
Well, because which one? معليش.
اللي بالأصفر اللي هو الشورت سيركت.
Oh yeah, because remember the magnetization. I don't know if we have the figure. Yes. So the magnetization curve is between B and H. يعني originally it's B and H, right? But also H is more linked to IF and B is more linked to the flux. So we can see actually that if we draw the curve between flux and IF, the behavior will be the same as BH, which is nonlinear, right?
Yes.
So if we draw also the flux is more linked to the voltage. So if we draw the relation between IF and the voltage EE, also it's going to be the same behavior as the BH case. So it's between the current IF and the voltage here, not between the current and the current. You get my point?
Yes, yes.
So just an example to digest all of these concepts. So we have three-phase Y-connected two-pole synchronous machine generator is rated at 300 kVA, 480 volt, 60 hertz, 0.8 power factor lagging. So we know the meaning of all of these values now. The open circuit circuits are given in the table. So you have the table and you have the IF. When you change the IF from 1 to 10, you have the open circuit voltage. It's going to be line to line because it's between the two terminals. So we record the voltage from 120 to 560. Just give me a second, معليش يا شباب. Okay, so yeah, we have the IF and we have the corresponding open circuit characteristic voltage, again line to line. And we have the current, the air gap line voltage, not the complete values. They're making it easy here. And all the short circuit current, not the complete values, only for the rated voltage. So the question is find if the armature resistance is neglected. What does that mean to you, the armature resistance is neglected?
Z equals XS.
Yes, there is no need for the DC test, and Z will be excess directly. Determine the unsaturated synchronous reactance. Unsaturated circle. So unsaturated,
You go with the air gap.
air gap, exactly.
Yep.
So the first step is to find what's the rated voltage. What is the corresponding value for IF and at the rated voltage? So the rated voltage is 480. That's it.
Okay.
So the corresponding value is 5. So to find what is Z or X at this,
لازم تروح الجراف.
yeah, but we have table here. We don't have a graph.
Oh.
So we need to divide the
480
voltage phase by current from the air
على
gap.
5.
Okay.
Yep.
So what is the first of all, let's find what is the voltage phase.
divided by root 3.
Yes, 480 divided by square root of 3. Why we are dividing this by square root of 3?
Because
This
Y
is line to line.
connection.
Because this is line to line and this is Y connection. So we need to divide by square root of 3. What if it is delta?
It will be the same.
دكتور.
No need. The same.
No need. The same. Same
No need.
thing. We take it as is because line to line is the same as the phase in delta.
Yep.
What about the current from air gap corresponding to this value of the rated voltage? Well,
5.
no, not this one. Not the field current. It's the armature current corresponding to this. So as I said, they're making it easy. Otherwise, you will have many values here, right?
Yes.
From the curve. But they're not putting this in the table, in this example. So you go and you find what is the corresponding IF, and after that corresponding current from line to line. So this is 600.
طيب دكتور لو حطوا أرقام أو عبوا الجدول إيش بيفرق؟
Nothing. You need nothing. That's why you don't need all of these values.
يحتاج بس الأرقام اللي عطوك اللي هي يعني.
Yes,
اللي
you just need this value which is corresponding to the IF, which is corresponding to the rated voltage.
Yes.
So table is much easier because you go directly to the values. Graph, you do it graphically.
دكتور كيف ال AP line refer to the IF?
The value that will give us the 480 from the open circuit test, the field current will be 5. So if you apply 5, you get the rated voltage here. And if you apply also this 5 to the short circuit test, you will get 600 from the air gap line. Okay.
دكتور الحين ليش ما قسمنا على 5 قسمنا على 600؟
لأن 5 هذه الاي اف different circuit هنا لحالها. أنت تبغى تجيب الاكس اس اللي هنا في السيركت اللي هنا، صح ولا لا؟ هذه اي يعني هذه ما لها علاقة، تقسم عليها ما يجيب لك شيء لأنه في سيركت ثاني.
اوكي.
اوكي. ما فهمت عليك معليش. اوكي. Yeah, but it's not يعني you want to find a way to link between this to this because يعني if you increase the current, the voltage will increase, the current will increase. Yeah, but this is what we are doing, but using direct values in this side. No need to go and يعني complicate things to the other side. What if my question is find the saturated value or synchronous reactance? What do you think will be the difference here?
again دكتور معلش.
What if the question is find the saturated synchronous reactance?
We go to the
بيتغير انك بتتعامل مع الاو سي سي على طول.
So what will be the value down there?
360.
ذكرت 360.
So we use this
تروح على
value
short
from
circuit.
the short circuit test. Yeah, that's it. So this is basically what you are gonna do in the lab today and tomorrow. You will draw both curves and theoretic, يعني from the curves you find the value of x is